Hello, I'm Jack Garzella, and welcome to our Primers video series where we try to ground you in various technical and business concepts and how to marry the two, similar to what we do in our Business and Tech podcast on Spotify and Apple if you want to look for that there. This is on YouTube. We're at End-to-End Results. That's our channel. So if you wouldn't mind subscribing, and then definitely leave us comments about the content, other subjects you guys would like to hear. Would love your feedback. If you want to get me directly, I'm Jay Garzella on Twitter and Jack Garzella Official on Instagram. You can also just email us at info@endtoendresults.com if you have any questions or would like to contact us on anything. Well, I do a lot of work with businesses, trying to get them to grow, get them to be purchased, fix profitability, fix revenue, scale their systems. And basically I started this series because there's a huge disconnect between what executives know, what technical guys know, and their communication. So bottom line is, that's what this series is about. So hopefully find some of these subjects relevant to you, and definitely leave us feedback, and we look forward to interacting with you in the future. Thanks a lot. We'll get to our subject right now.
So today we're going to learn what's a server. And you're probably used to physical tower servers like in your house or at work. But really what we're going to be talking about is data center servers today and how those work with application servers, how physical servers deal with virtual servers. It might be a new term for you, might not be. And then how application architectures drove a bunch of change, which created a bunch of new terms like services and containers and pods and things like that. And again, this presentation is for high to mid-level managers, both in IT as well as on the business side. Excuse me. If you're an IT guy that knows all of this stuff, you're going to be bored. In fact, you're going to be saying, why didn't you put more detail in here? So key is this is just to get everybody grounded in what these terms are and what's going on. So we're going to discuss this in kind of 5 steps of what a server is, how they work with applications, physical versus virtual servers, which is one big change that came into place, the impact of application architectures, containers, and pods. So that's what we'll be talking about today, and we'll learn how all this works. And again, I want you to learn a couple of terms: physical versus virtual server, virtual machine, tiered architectures. We're going to learn about these things so you guys can be smarter. Okay, let's get to it. So the problem we have. Well, the problem we have is the classic server architecture really doesn't support well these mega applications we have today. Google search and Amazon and eBay and things like that. As we got into the late 1990s and into the 2000s, these server architectures are really starting to cost us a lot of money, and were very, very manual labor intensive to deploy. Now, what are some applications that were giving us trouble? Clickstream tracking. This one I was very involved with. I was a CIO of MatchLogic. We tracked back then, we tracked almost every click on the internet between us and DoubleClick. And that 1-by-1 pixel that follows you around the internet, we did that. And then whether you opened an email, opened and clicked on it, those kinds of things. So the key is that's a lot of data to track and a lot of things to keep track of and to process after the fact. Internet search today, Google, Yahoo, Bing. Remember back in the day of Alta Vista? For those of you that are over 25, 30. Anyway, e-commerce sites, Amazon, Overstock. We mentioned a few of these already. Streaming services. So what I want you to really notice as I go through these is the right side here. None of these problems are the same, right? We have different problems here. We need to filter a lot of data. Shopping has lots of transactions and huge spikes during Black Friday and things like that. When I was at Overstock, we had to deal with that. Large file sets, Netflix, Disney Plus, large file sets that have and need a lot of network bandwidth. And then we need to ensure fast browsing speeds, right? So those are the kinds of things that were really hurting our ability to get into the next level of scaling, really, to scale these applications. So what's a server? Let's go backwards here a little bit. A server stores and sends data, and it receives data. Modern definition today is a computer program or device that provides a service to another computer program and or its user or client. So if you notice, that's just a generic way of saying server. And we're going to get to why that is here as we get into cloud computing. So our classic traits here are physical hardware versus processor, memory, and disk. We normally have a operating system like Linux, Windows, Mac OS, right? We gotta have, it's got to run something. Otherwise, it's just a piece of metal with some silicon. And then finally, we have the modern definition. We can virtually allocate processor, memory, and disk to each server. Okay. Now, this can't be done in a physical way, right? With these physical servers you see pictured over here, but we can do that when we're using cloud computing, which we'll get into here in the next slide. Finally, the only way to really scale these things physically was horizontally and vertically, meaning I could add a bunch of web servers. I'm going to show an example of that. I could add a bunch, make a much bigger database server. That's kind of vertical, if you will. But that was pretty limiting, very limiting. In modern days today, we want to virtually be able to scale horizontally and vertically and really dynamically even as we get the workloads change. So how did cloud computing change this stuff? So, mid 2000s, cloud computing came of age. Isn't what it is today, but back then we started using it. And basically servers became virtual servers to us because they weren't in our data center, right? They're not in our data center. They're virtual, right? We're using them on somebody else's data center. So they, instead of being physical, we were able to access them and use them like they were our server, even though we weren't maintaining them, we couldn't touch them. So there's many types of servers available. We have, balanced servers that are kind of like a PC or whatever. They have some disk, they have some IO, they have some CPU, but we can get optimized servers. We can have memory optimized servers for caching, things like that. We can have disk optimized servers for databases and file storage, file retrieval. We get very small servers if we just need a really small one to do a few small tasks. The point here is that we can get these on demand in cloud computing. We don't have to have them running all the time. So I could go into my AWS account today and I could say, give me a server that has, 4 cores of CPU and has 32 gig of RAM and has X amount of disk. And they will pop that up for me in a matter of minutes and I'll be able to use it. I can also, when I'm done with that, tell them, okay, I don't need it anymore. Let's have it go away. And this is where we get into virtual servers, okay? And we only pay for them while we're using them, although we can prepay and do lots of savings plans and things like that to save costs. Now, the reason that cloud computing helped drive a lot of our application deployments is because as soon as you come into this virtual world where things aren't physical, you have a lot of flexibility. And that drove application architecture, which we're going to get into in points 3 and 4. So again, I kind of covered this on the right side, but we can request servers, we can request data storage only. We can request caching services only from cloud computing, serverless, right? We won't go into that in detail today. It's a little bit of a mind bender, but maybe we just need to process something. We don't need to store any data, network services, things like that. Point is that these guys, AWS, Azure, Oracle Cloud, Google Cloud, they can be our new data center now. We don't need to have one. But servers and applications work together. Now, you can kind of look at the pictures on the right side while I'm talking on the left side. Basically, applications, from 19 whenever until really the mid 2000s, or actually, let's go early 2000s, late 90s, were written monolithic, right? One program, you installed it on a CD, it's one big set of execution instructions, and it ran, okay? Then we came into tiered. So tiered definitely started in the 90s, mid to late 90s, where we kind of separated the user interface from the database layer, from the business logic layer in the middle. And that was good. That helped us tier things, and we could have 3 horizontal tiers. Then you kind of see that in that upper diagram over here on the right. So you'll kind of see that. And then again, we dominated that. We put them into those 3 layers. However, as we got into the mid to late 2000s, that still wasn't enough. Our applications were getting bigger. Our demands on the processing were getting more complex. So we had to move to a services architecture. And today, this is kind of the standard for large programs. Now, if you're just creating a small app or doing a small program, you generally wouldn't use a service architecture, at least until you need to, till it grows. But any kind of large deployment today will use service architectures. So we break the application up into very focused components. And that's kind of what you're seeing on the lower right-hand diagram here. We have billing and payments and web usage and trip management and notifications. They're all broken up into different quote unquote services. Okay. Services talk to each other and work with each other via APIs, application programming interface. And don't let that kind of scare you, but basically all these things do is they request information, provide me the name of client 1234. And then in the reply, they get back, oh, it's Jack. Or you might get an error saying, I can't find 1234. That's all an API is. So don't get scared of that, but that's how they talk to each other. So services talk to each other through the APIs. We use APIs all over the place back in the 90s, 2000s. Today, they're very, very common. Now, let's use an example from late 1990s. I actually took the architecture here. It's way oversimplified here. In fact, anybody that used to work with me would be laughing at this, but I think it's good for this presentation. So I don't want to get too technical. But basically, we had to process all these ads that were serving for General Motors and Procter & Gamble and Charles Schwab on the internet back then. And we had to collect all the clicks. We had to know who was clicking on them, at least from a cookie perspective. And then, because we did do it anonymously. And then we had to be able to process that data back for reports and tell marketing who was opening the emails and things like that. Now, what we did is we broke it into tiers, of course. Now we had multiple data centers around the United States because we had to serve those ads quickly. So the first thing we did is we put a bunch of very fast, back in the day, 64-bit. Again, I'll be showing the age of this project here, but DEC 64-bit web servers out there to serve the ads. 64-bit is very common today. Back then, that was one of the first servers you could get and buy for a reasonable price that was 64-bit. But we put a rack and stacked hundreds of those in these data centers to serve the ads. And they would produce raw text files for us, just raw data. And then we would pull that data in through the network from the various data centers back to our home office data center. We'd process and filter it. We had a couple of servers doing that. And then get it ready for the final load into the database. We would process it there and have it available for users and reports. Now, when I got there, not going into this too much, but when I got there, this process for an hour's worth of data took almost an hour. And that's one of the reasons they hired me, is they needed to speed this process up. And most of the problem was on the back part here, the home office part. The data center part was working pretty well. So we re-architected this entire back end. And again, this is super oversimplified for this presentation, but we got it down to 5 minutes to process an hour's worth of data. This architecture looked a little different. It was more real time. We got rid of all the batch processing. Now, that's neither here nor there, but the point is that things evolve over time as you grow. Virtual servers helped us solve this problem. So we have a lot of wasted resources and energy when you're just racking and stacking a bunch of database and a bunch of processing servers and web servers for that matter, right? At night, they're not doing anything. They're just sitting there spinning disk and using CPU. During the day, I might not even have enough, like when I got there and they couldn't process a full hour in an hour and they were going to buy bigger servers to do it faster. But eventually you can't buy a server big enough to do it. So virtualizing the environment really helps. So virtual servers are the first step of that. And basically what you're doing here is you're saying, okay, I'm going to take one large server, I'm going to break it up into multiple small virtual servers that look like each of them is an actual server. They're really just a slice of the physical server. So maybe a virtual machine has 25% of the memory and is allocated 25%, or let's use this example in this diagram on the right, 33% of the CPU and memory for each of those virtual machines. Now, you can actually adjust that. It doesn't have to be even. But for the sake of this, again, keeping things simple, we're just going to say that it's even for the moment. Typically, it's not, though. What this does is it recreates the functionality of a dedicated server without having to use that. And now we can deploy as many of these virtual servers as each of the physical servers can handle. But what's nice about this, as we get into the application architecture, that first virtual server might be a web server dealing with the browser. The second one might be, or we might have two more that do the business logic. And we might just have a final one that does the database, or maybe the database isn't even running here. And we do that through the network APIs, which is typical. So that's the idea behind these virtual servers. And we have to remember that virtual servers, again, can be sized differently. Not every server needs the same resources. A database server is typically large. It's going to have a lot of CPU. It's going to have a heck of a lot of disk and a heck of a lot of disk throughput, right? Disk IO, input output. Web servers, they need more network and CPU, and a lot of them don't even have disk or very little disk, just enough to run the operating system and the virtual machine. So when you look at this, they're basically broke down into kind of three areas. The first one being business logic servers. I think we all understand those. That could be your invoices, your pricing. Does this guy have an account balance? Things like that. The next two, though, might not be as obvious. We have service processors and caching servers. So service processors generally are just memory and CPU. They're going to use APIs to store disk. And then caching servers, we use these all the time in browser applications so that we can make the screens really fast. So instead of going back to the database or back to a file set every time to get an image or get a piece of data, we cache it. We store it in memory somewhere out on the network, generally not at the home office, but somewhere out on our cloud to be able to produce really fast screens for the end users. Now, again, these are gross oversimplifications for anyone that's super technical watching this, but you get the idea on how this is going to work. So we can adjust memory. We can adjust CPU, network, and disk for each of these servers, okay? And this is done all the time now. So, and if you're new to this, a lot of the AWS, Azure, they have a lot of recommendations now for you on, if you want to do this or you want to do that, kind of here's what you need to do, or here's the type of size of server that we would recommend. Okay, moving on. Now we're going to get into the impact of these application architectures. Okay, so virtual servers really did impact the way that we started thinking about application architectures, because now not all of our services and our tiers needed to look the same. We could break down an application into its most basic services, kind of like you're seeing on the right-hand side diagram here, into billing, payments, and passenger user interfaces and driver user interfaces and notifications. We break those down into the smallest component and then deploy them. However, how do you deploy a service? Is it just code? Is it a program? Do I got to compile it? Well, that's where containers came in to be. So that's a new term in this presentation, but a container is kind of what it sounds like. It's a self-contained copy of the service or application, full application in the legacy sense, and a service in the newer sense. And everything in that container is there that it needs to run. So literally, when I grab a virtual server, I can just grab the container, copy it, pop it onto my virtual server, hit run, and boom, it starts going. And if I can run 5 of those on a virtual server, great. If I need to run 1 per virtual server, great. We'll talk in section 5 about how we deploy that stuff. But basically, these containers, while they're not like virtual servers or virtual machines, that's exactly what they do, though. They have all the stuff to be able to run, but they still need a virtual server to run on. Okay, so that's kind of what those are. And we'll see now why that's important. So we have a lot of things to manage now in these new architectures. We have physical servers, virtual machines, which run on, are almost synonymous with the virtual servers. We have containers, of course, the apps inside the containers, and then we have services that get deployed. The interesting thing is that these services and containers are very tightly coupled, so that if we have a spike, we can automatically deploy them. We got these automated deployment architectures in the solution here. Kubernetes is the most common one used today. At least I'll say that, because that's the one that I see every day and go to conferences on and everybody talks about. This is the most common one used today. I wanna just be clear that Kubernetes is not for the faint of heart. It is for experts. This is not something your guy out of college can just come in and do for you, or some coder that did your, your marketing website is going to understand. It takes some training. It takes some really experience on a larger team normally to be able to understand it and deploy it. Now, AWS, Azure, and everybody's trying to make Kubernetes easier to use. But for the moment, it's still pretty much an expert type service. I use it, or I should say we use it with several of our clients right now. And we scale up and scale down dynamically. So we scale up like at 6 a.m. And then we scale everything back down at 6 p.m., 8 p.m., whatever. We kind of watch the CPU. It does all that automatically in the background for us. And it takes those containers and pops them onto new virtual servers, and then it destroys the virtual servers when we don't need the volume anymore, don't need the processing power. It's currently in vogue. It's what's mostly used today. You can see the right-hand side. I've got a couple pictures of the way Kubernetes works. I do not expect you to understand any of this. But what I do want you to understand is look at this lower diagram here, and you'll see that we have these things called pods, okay? Kubernetes deploys pods, and inside a pod, we can have one or more containers running, generally one. At least that's the way my team does it, but that's probably because of the way our applications are written today. But you can have multiple containers running within a pod, okay? So Kubernetes basically will bring up and down pods with certain containers, i.e. certain services, and you can configure that to work, again, based on CPU usage, network usage. There's various metrics that you can use for that. You also see another new word here, Docker. Docker right now, again, kind of like Kubernetes, it's the most used container technology out there. So when you're creating containers, you'll hear people say Docker containers. That's what it is. A Docker container is a self-contained application container that has the code to run the app, all of the utilities, the basic that it needs to talk to the operating system, and then it can be deployed onto a virtual server or virtual machine to be able to run. So that's what I wanted you to notice over there. This control pane here, just to mention it, this is what kind of watches that, do I need more pods? Do I need more services? Do I not? That kind of thing, very simply. Again, I'm kind of oversimplifying this again, but that's there's a reason for that. Is we're not trying to train you on this. Now, you might wonder, where does this stuff come from? Who thinks of this stuff? Well, it's Google, it's Facebook, it's people like that. They have to deploy some of the largest applications in the world, especially Google and Facebook, and back in the day, Yahoo. And they basically create this stuff, and then they open it up into the open source community for the most part, so that others can use it. That's it, really. So they get some free development out of it because people enhance it. Okay, moving on. So for a larger application, again, on the left-hand side, we're already assuming our application's been written in a way that it can be tiered and or used in a services mode. And now you can see here that we've got our physical servers with virtual machines running pods that will run containers. We'll show that on the next slide. So basically, you'll see on the last slide, I'm going to describe this as an onion, right? So here's the onion. So let's just break everything down that we've talked about today here. Even though this isn't the summary slide, we're going to talk about this as the summary slide. So we have physical servers, which may or may not be using shared storage. We virtualize those. Each of those can have a different virtual machine running. And if we're using Kubernetes, we're going to create pods, and those pods will run different containers that have our different services, such as on the lower right-hand side here, the billing service, the payment service, things like that. So I can spin up, again, let's assume pod one is kind of the web layer, the user interface layer. I can have 3 of those, even though I only have, I can have, whoops, sorry about that. I can have, looking for my drawing tools here. There we go. We can have 3 containers running our web application that's servicing the browsers, but only one doing payments, and maybe we have another pod doing billing and invoicing, because this pod has some special, that container / pod, it's really the container though, has some special code in it for security, because it's doing payments that we don't want to share with invoicing and billing, so we separated those services out. And that's kind of the idea of how that all works. Again, this is not for the faint of heart, but I think you know enough now to look maybe not smart, but at least not dumb in front of your technical team. Okay, so the summary of all this, if we go to the summary slide here, is that physical servers just aren't flexible enough, and they haven't been since early 2000s. Large applications don't scale the same, have the same need. We can only scale them up in size, right? More CPU, more disk, or scale them horizontally and vertically by creating more of them. So what we're going to be doing is creating virtual servers, probably in the cloud, although you can do this in your own data centers like the government does and people like that. We all used to do when we didn't have cloud vendors like AWS and Azure the way it is today, at least. When we create these virtual servers, we can have multiple ones on a same physical server. These technologies are all mature. These virtual server, virtual machine technologies are very, very mature. Kubernetes is getting mature. Wouldn't call it fully mature yet, but it's certainly not. It's not leading edge anymore. I would say it's leading edge from the perspective of not everybody knows it, but the technology itself is relatively well proven at this point. And then we come down to the application architectures here, and they matter a lot, because if we don't have an application architecture that breaks things up into components, it's very hard to create tiers. It's very hard to create services, and then it's very hard to containerize those things to be able to deploy them on demand. And again, not all applications, not all services need to have the same level of resources. And finally, Kubernetes, like I said, it's common. AWS and Azure supported. Almost everybody supports it today. You can pull it down and run in your own data center if you want, which I know people have done that. It is complex. Again, it's not just push button, let's go do this in Kubernetes. There's a lot of work to be done. Your developers have to use containers. Your DevOps team, development operations, they need to be able to know how to use it and manage it. And you have to have, your application team, your server deployment team, everybody's got to be on the same page as to what that looks like. So you need a really good architect, CTO architect that knows how to put all that stuff together. But if you don't want to do all that, that's fine. You don't need to do all that, at least initially, especially if you're small. Virtual machines are a great way to start. Virtual servers are a great way to start. So hope that helps you out a little bit today. Try to keep this to under 30 minutes. Kind of hard with this particular presentation, but again, if you got questions, just DM me, hit me up on End Results, Twitter, Instagram, all those places you can find me. And we look forward to seeing you on our next primer.